Section 5.4, dividing polynomials. So we're going to practice long division. We're also going to practice synthetic division. Synthetic division is way easier, but you can't always do synthetic division. So we kind of have to know both. And you'll know after we do synthetic when you can use it and when you can't. So that's what we're going to look at today. So here's problem number 1. Use long division to divide 4x squared plus 23x minus 16. We're going to divide it by x plus 5. What they're looking for is what is the quotient, what is the remainder. So basically the full-on answer split into 2 parts. So what we're going to do is we're going to put the x plus 5 on the outside. Oops. And these kind of take up a little bit of room. And then we're going to put the other part on the inside. However, we have to really pay attention to the exponents and see if it's in complete standard form or not. If there's something missing, we're going to put zeros in for those. So on this one, we started with squared, then we went to the x, then we went to no x's at all. So this one is totally fine the way it is. We don't have to fill in anything that is missing. The difference between the long division and the synthetic is that in long division, all the variables and numbers are there. In synthetic division, it's only numbers. And I think that's what makes it easier, and it's a simpler process with the synthetic. So when we are looking to divide, the only part that really matters, I mean, not that the other part doesn't, but the part that you really look at is this part. The 5 kind of just trails along with it. So when you're multiplying it through, it's the x that matters, not the other part, when you're trying to figure out what goes in there. So the first thing is we're trying to put x into 4x squared. So the number is going to be 4. So 4 times x will just give me 4x for now, but we do need the exponents to match. So most of the time, if this is a 1, you subtract these two to get the variable on the x, kind of like we did yesterday when we took something out. It's that same process. So I'm going to put an x by this one, and then check it. Does 4x times x equal 4x squared? Yep, and I haven't even looked at the 5 yet. The 5 is kind of just a trailing number. So now we're going to multiply. So 4x times x should match it to be 4x squared. Then you have to bring that 5 into it. So 4x times 5 would be plus 20x. And what I usually do, and we're going to subtract it, is if you have 2 parts or 2 terms on the outside, you should have 2 terms when you multiply. So the number of terms here matches the number of terms there. Yep?
So to get your 20x, you don't even look at for 23x.
Nope.
Looking at the top and the outside?
Yep, all I'm doing is multiplying these two.
Okay.
Yep. It's kind of like distributing the 4x to the x plus 5. That's all we're doing. Now we're going to subtract them. So 4x squared minus 4x squared cancels, and it always should. 23 minus 20x would give you 3. You can go in there and change signs if you want to. I just use parentheses and put a minus on the outside. But just make sure you're subtracting when you're doing this step. And as always with division, you need to bring the next term down, so it's a minus 16. Also for that, we only had 1 term here. We need 2 because we're dividing 2 things into it. So you always need the numbers that you're looking at to match.
Why is there 4x on the top?
4x squared divided by x. So x times, or 1 times 4 would give you the 4. X times x would give you x squared. And you could look at it like this too, if this helps. Let me change colors for a second. You are dividing 4x squared by x. What do you get? 4 divided by 1 gives you 4, and then you subtract those exponents. So we're dividing numbers.
So would it be like if we had 4x times x divided by an x, so then 1 cancels out?
Yes. Yes. Same thing. Yep.
You times 4x times 5, right?
Yes. Yep. So now we are going x into 3x. I'm not worried about the 5. I'm not worried about the negative 16. It's only the leading variables that we're worried about. So on this one, it kind of looks like this. You are dividing 3x by x. What do you get? That looks like a weird x. What? 3, right? So we're going to do plus 3. And now the multiplying takes place once again. So it's kind of like we are multiplying this to get this line that I'm going to put right there. If that helps, you can kind of scoot that off to the side. This one was 4x times x plus 5. Gave you that one. Okay, so it's kind of like a little mini distributive property. So 3 times x would give you 3x. And 3 times 5 would give you positive 15. And then we are subtracting the whole thing. I'm going to try to change colors here. There we go. I'll do that so it stands out a little bit more. Okay, so 3x, subtract 3x gives you nothing. I'm going to not write anything. And then we have a negative 16 minus 15, so we have a negative 31. Now, is there anything else to bring down? No. So then you just leave it. So that basically is your remainder. So once you run out of terms to bring down, you're basically done if it doesn't match the number of terms on the outside. So this is 1 term, that's 2. We can't do any more. Yep. Yeah, you're subtracting those at the end, so it's negative 16 minus 15 because you have to subtract. So now the question again was, what's the quotient? What's the remainder? So my quotient is 4x plus 3. My remainder is negative 31. You don't really have to put it together at this point because they're asking you kind of a separate question. If it said divide, it would look a little bit different when we wrote it. If it just said to divide to get the answer would look like this. 4x plus 3. Generally, you go like this. You know how when you're doing that long division, you have a fractional answer? It's kind of like that. They didn't ask us to do it that way, but that's what it would look like if they just said divide. What you do is you bring this remainder up to the top. The book, I think, puts the r in there, which is fine, I guess. You could just do r negative 31. But if it asked for like fractional remainders, then you would put it like that as a fraction. Right now, they just want you to keep them kind of split. Is it easier for you when you look at what you're multiplying on the side? If so, do that. Put it off to the side. Makes it a little bit easier. You don't have to do arrows to where it goes. I'm just kind of showing you where those numbers are coming from. Just make sure that when you're bringing numbers down and multiplying, you're subtracting those. Okay, just for practice, I want to do one. I put it at the end, but I want to do it now. Yeah, let's do this one. You can just do it in your notes this time. So first thing, remember that you check is x squared x number looks okay. We don't need any fillers. We don't need any zeros or anything. The biggest thing that you read first always goes on the inside. The x minus 7 always goes on the outside. So what are we trying to divide? Which two parts are we dividing this time to get that first number? Yep, so 3x squared divided by x. That's what's going to give me that number that I put on the top. And what does that give me? 3x. So one of those x's basically cancels out. When you do the exponents, it's 2 minus 1, so you just get 3x. Then what we're doing is we are multiplying 3x times x minus 7 to get this line right here. Okay, so we're multiplying the thing that's on the outside with that thing that we just put on the top. 3x times x would be 3x squared. 3x times negative 7 would be negative 21x. And then we subtract that. Now, remember, if you're going to forget signs, change both the signs. That's the same as subtracting. I'm just putting parentheses around it and kind of talking about it or talking as I do it. 3x squared minus 3x squared cancels. And then we have negative 29x minus a negative. That would be a plus 21x. So we get negative 8x. There's two terms on the outside. We still have one term left to bring down, so we're going to bring that down. And then we're going to do that same process one more time. So for this one, what are we dividing? What do we need to figure out to get that top number? Negative 8x divided by x. So first term of the one underneath, first term of the one on the outside. When we do that, basically the x's cancel, and you get minus 8 sitting at the top. Then we do a little distributive, negative 8 times x minus 7. That is going to give us this line right here. So we get negative 8x, and those two always match right away. And then plus a 56. And then we subtract both of them.
So minus 56.
Negative 8 times negative 7. Eventually it'll be minus when we subtract. So if you just change the signs, it would be plus 8 minus 56. So negative 8x plus 8x gives me nothing. 56 minus 56 also gives me nothing. This time the remainder is 0. Yep.
How did you get the second negative 8x plus 56?
This one. I did that first number divided by the first letter up there. Like this one.
Negative 8 parentheses x minus 7. How do you know to do that?
Oh, it's right here. This one times that one. Whatever you write at the top times whatever's out the outside, but you can only do that little part.
So it's like when you did like 3x.
The 3x was the first time, the 8 was the second time, yep.
When our remainder is 0, do you have to write that like?
Yeah, if they ask you for the parts, so we'll finish it out right now. It looks like this. So quotient, I'll put a Q with it, is 3x minus 8, remainder 0. If it was just a normal division problem, you would not have to write any remainder. You would just say answer's 3x minus 8. And remember always that if you multiply these two, like the whole thing, times that by using FOIL, you should get what's underneath that, that little division symbol. Does that make it easier? Putting it on the outside and looking at it. But remember, this thing right here is only the term you put on the top for that one time. So the first time we did this times this, the second time we did this times this. So it's only one part at a time. And we're making it smaller so we can't do everything all at one time. Okay, so going back up here. In this box, sometimes we have remainders and they ask for questions like this. Is x squared plus 1 a factor? If the remainder is 0, it's a factor. If the remainder is not 0, it's not a factor. It just means it doesn't go in there evenly. It's kind of like when you are looking at the number 15 and I say, is 2 a factor of 15? And you say no, because 2 times something doesn't equal 15. It's kind of like that. So we're going to do the same thing, except we've got some missing items this time, so it's going to look a little bit different. Okay, so x squared we are missing the x in there, so I'm going to put a 0x plus 1. And you do the same thing underneath. So if there's anything missing, you have to fill it in with a 0. So we have x to the 4, that looks good. We have an x to the 3 next, so that's okay. Then we have our 2. There's no x in there, so I'm going to put a 0x, and then I'm going to put a 5. All of these need to go down by 1 every single time. So if you're missing any of those, put a 0 in. And even if you miss that at the beginning, you're going to know in like 2 seconds. I'll kind of show you where you would get a clue as to what you maybe didn't do. Some people put them in, some people don't. So I think for now, you should put them in because then you're going to know if you're missing anything. So the thing with this one is we have 3 terms, but it doesn't make the process any different. It's going to be exactly the same that what we just did. I just don't have a lot of room on the side to put what we're dividing. So on the first one, we are dividing these 2. Okay, so what is 3x to the 4 divided by x squared? And 3x to the 2 this time. Usually it goes down by 1. This time it doesn't because this is a 2 out there. And if you need to see it, jot it down on the edge. Looks like this. 3x to the 4 divided by x squared. So again, you subtract the exponents, divide the numbers. Okay, then for this one, we're taking what we just wrote at the top times what's on the outside. Would I need the 0x in there when I multiply? Not really. I'm going to skip it, but you could put it in there if you wanted. Okay, so now I'm multiplying. 3x squared times x squared is 3x to the 4. 3x squared times 1 would be x squared. So here's where, okay, I'm going to leave it in this time just to kind of show you what I'm talking about. You can leave it out, but what happens if you don't, or if you do leave it out, you might have something in the wrong place. And here's where I'm talking about that. So in the next one, 3x squared times 0x would be 0 x to the 3rd. If you leave that out, you would be skipping that whole step and you'd only have 2 things. You have to get them in the right column, which is sometimes hard when we're doing this for the first time in a year and a half. Then we're going to multiply 3x squared times 1, which would be 3x squared. So what happens is if you skip the 1 in the middle, you have a blank space here, which also means 0, but you got to get it in the right column so that those exponents match. Okay, so it might be easier just to multiply through all 3. Then we're going to subtract them. And again, you can use opposite signs if you want, or parentheses, whatever you want to do.
Where did you get that negative?
You have to subtract. The one that I just wrote in there. Yeah. When you're dividing, you always subtract when you're doing that second step. So it's just from like way back in 4th grade when you guys learned, or 3rd, whatever, learned long division. Okay. So you always subtract. These are gone. Negative 4x minus nothing is going to be negative 4x to the 3rd. 12x squared minus 3x squared would be 9x squared. And then how many terms do we need? 3, because there's 3 on the outside, so I need to bring this 0x down. Now, for the next one, what are we dividing? To the 3rd by x squared. So for this one, we are dividing negative 4x to the 3 divided by x squared. So what do we get? Minus 4x. Now, you kind of can get in a pattern because if you can get the first one, these usually go down by 1 every time. So if you have something that's bigger than what you started with, you didn't do it right. Or if you have it the same, it should be getting smaller. So for the next part, we are multiplying negative 4x times that thing on the outside to get that one. And if you can do that without writing them on the side, go for it. If you need it, write it, because I think it definitely helps so you're not looking and getting signs wrong and stuff like that. So we have negative 4x to the third plus a 0x squared minus a 4x. And then we subtract the whole thing. Those cancel. We have 9x squared minus 4x. Again, we still have one number that we have to bring down. So basically, 3 terms on the outside means you probably have to do this 3 times. 2 terms on the outside, you got to do it twice. You know, it kind of tells you how many things you have to do. For the last one, we are dividing 9x squared by x squared. So what are we going to put there? 9. So we have a plus 9. Yep.
It would be like a negative 9x. That's how we get like minus 9.
Yes. Okay. Yep. So whatever the sign is, you do need to include it. So she's saying if this was a minus, would you put a minus here? Absolutely. And then you might have a minus sitting at the top. Okay, so like on this last one, this was a minus. I brought it in there. We had a minus on the top. Okay, so we're multiplying 9. Do I have orange still? No. 9 times the thing on the outside is going to give you that one. So 9x squared plus 0x plus 9. And then we subtract the whole thing, and we are finally done. Long division is not something that I enjoy. It is what it is. And it's kind of one of those things that you cannot make it shorter. I mean, this process is the process. It's not anything different. Okay, so then we subtract them all. This one cancels. We get negative 4x, and we get negative 4. So here, this is my remainder. So is my answer yes or no?
No.
It's no because
Wouldn't that be
5 minus 9 at the end?
no? Okay, so not the last subtraction you did.
Okay.
Above that.
Yep.
The
Oh, that should be a plus right there, right?
yeah.
This should be a plus. Yep. Go back to right here, guys. I'm putting a plus right here. I did not do 0 minus negative 4, so change that to a plus if you were looking at mine. And then that would change this one to a plus as well. Thank you. Okay. So if you have a remainder, the answer is no. And basically when you circle your remainder, that's the reason. If you had a remainder of 0, you would answer yes. And that just means that it divides in there perfectly, and that's what we want. Okay, so here ends the long division. Enter synthetic, which is way better. Okay, so here we go. If you want to write the steps, you can. Once you do it probably twice, you will know exactly what to do. So it's not a hard process, and I think you guys did this, and I think when you write it down, you'll go, oh yeah, I think we did this before. It looks familiar. So we're going to use synthetic division. We're going to write the coefficients, including the zeros, in standard form. So you still have to get them in order, descending order. We're still going to put in zeros for the missing things, but you're only going to write the numbers that go with those variables. Okay, so if you have them in order, if it was a 2x squared, you'd write the 2. If it was minus 3x, you'd write a minus 3 and go down from there. So it has to be in standard form, and you're going to fill in the zeros when you can. Okay, I've already said you don't use the variables, which makes this easier because you don't have to keep track of so much stuff. Okay, and then for the divisor, reverse the sign. This is a big deal right here. You always have to remember to reverse that sign. So for instance, if you were dividing by x plus 7, you would be dividing by -7 in the synthetic division. And basically what it means is this. If you do x plus 7 equals 0, you get x equals -7. That's what you would be dividing by. So that's kind of what it means. And this says it allows you to add in the process instead of subtracting. And we all know that adding is far easier than subtracting, because then we don't have to worry about as many signs. Synthetic division is one that once you know where the numbers go, you don't even really have to think about what you're doing. That last thing, there was a lot of thinking going on during that because there were so many steps. So I think you'll go, oh my gosh, can't we do this for the rest of the year? Because it's going to be that easy. And, don't be super concerned about, oh my gosh, there's 3 steps, because, once you do it a couple times, you will know. All right, so here we go. First thing I'm going to do is change this. What do I make this? Instead of x plus 2, you change the sign of it, so you make it -2. Remember, it's kind of like you're solving that part. For setting it equal to 0, it's kind of like a factor. You need to know what number am I dividing by. That's kind of how you get that, but you can just go, oh yeah, I have to change the sign of that thing. So on the outside, I'm going to put a -2. And it's kind of like a reverse division symbol, and make sure that it's like 2 lines long. So we're going to have a row of numbers here, and we're going to be writing something there. Okay, so you might want to wait until I write it in there, and then you'll go, oh yeah, I think I remember. Then we check the thing that we want to divide into. We have cubed, squared, x, number. Looks good, right? So I'm going to take the numbers only. So the number ahead of the x squared is a 1. The number ahead of the x cubed, the number ahead of the x squared is -14. Take the signs and everything. In front of the x is a 51, and then we have a -54. So that's my top row. I'm going to need to put numbers in here in just a second. First step, every single time, bring this number down.
Is there a reason we aren't putting like plus 51 there? Like, is it just the
You can if you want to. I just don't put a sign when it's a plus. Yep. So bring the number down. That's step 1. Instead of subtracting now, we're going to add and multiply. So instead of dividing and subtracting, we're adding and multiplying, which is far easier for everyone. So multiply these 2, and I'm going to kind of guide you through this first one. I probably won't do it the second time, but multiply those 2. What is -2 times 1? Okay, goes here. Okay, so you multiply these 2 and you put it there.
So you just write the 1.
Bring it down. Whatever it is, bring it down. You don't do anything because you need kind of a starting point. Like if that was a 2 there, you'd bring down a 2. So it's not always a 1. You're just kind of bringing it down. Then you add the numbers. What is -14 plus -2? -16. Okay, now I'm going to change colors so that you can kind of stick with me here. We're going to do that same process again. Okay, so now I'm going to do these 2. What is this one times this one? Oops. Hold on. It wants to move me here.
Wait, so why did you do -14 plus -2?
Because that's the process. Instead of dividing and subtracting, we're going to add and multiply. Yep, that's in one of those rules above.
And what is the x stand for?
Multiply. If you want to put a dot instead of an x right here, we're really multiplying.
Oh, it's not like a variable.
No, it's not a variable. It's just multiply. Okay, now I don't know why this isn't letting me. I might be too close to the bottom of the page, maybe. Okay, keep it orange. What is -2 times -16? 32. And then what do we do with these? I should have put a plus here. We add them, right? 51 plus 32 is 83.
Wait, what? Wait.
Negative 2 times negative 16 is 32. So you multiply them and then put them under the 51. Multiply these
So
two.
If we would have a negative 14 plus a negative 2.
Yep, is negative 16. Because we're adding. Okay? Now, you get some wildly big numbers on this. Don't be alarmed. Because usually they work out. Sometimes they don't, but a lot of times they do. Last step, negative 2 times 83. That'd be a 166 negative? Okay. So, okay. I don't think it'll let me do my arrows this time. So this is negative 166. And then what do we do with those? Add them. So we get 220 and it's negative.
To get the negative 166, we multiply 83 times negative 2.
Yes. Okay, and I'll kind of put that. I don't think I can do that. Okay, now it let me. Okay. I don't know, this thing is weird. And then we put it there. So the next one, I'm not going to put all these arrows because it definitely is easier once you know where things go. Does that help when I go multiply, put it there, multiply, put it there, multiply, put it there? Then you add, okay? Now, the thing with this is it says what's the quotient and what's the remainder. This last number right here is your remainder. Okay, so I'm going to put remainder negative 220. And then we also need the quotient. The only thing that's different about the quotient is we're not going to write just the numbers because that doesn't make sense. We need to put it back in like a polynomial format. So this is a number, this is an x, this is an x squared. I always go kind of in reverse when I'm thinking about it. Number, x, x squared. So it goes like this. X squared minus 16x plus 83. So these three things, it doesn't like this blue color, I don't think. There we go.
So you only go to like x squared, like you don't need to go to like x cubed or anything?
If it's longer, you might have to go higher.
Oh.
Yeah, so like if there was a remainder here and there was 4 things, then you would go to the next one, which would be cubed.
But your last one will always be the remainder?
Yes.
What if it's above 5? How do you know?
You would just keep going. I mean, you just kind of keep going. And if you want to write underneath what one goes where, so here's your number. Here is the one that goes with an x. Here's the x squared, and you would keep going. So then you would write it out. If that makes it easier, do that. Okay, so the next one's going to be much cleaner. But we are going to do another one. Okay. So I'm not going to do all those extra steps this time. I'm just going to kind of do it. So do we divide by plus 5 or minus 5? Minus 5 goes on the outside because remember you have to change the sign in the middle. We're going to use 2 lines. Then we're going to look at descending order. Is it okay the way it is? So basically what I'm saying is what if this one was left out? If there isn't an x, you put a 0 in there. Okay? But there is, so this one's okay. So I do the numbers only. The number on the x cubed is a 1. Then we have a 7, then a negative 38, and a negative 240. And what's the very first step? Drop down the 1. So this one just comes straight down. You don't need the arrow. I'm just kind of telling you what I'm doing again. And then what do we start doing? Negative 5 times 1, and you put it under the next one, so which is under the 7. Then you add them, no changing of signs this time. So 7 plus negative 5 is 2. And then we do it again. What is negative 5 times 2? We put it under the next one, which is under the negative 38. Then we multiply, we already multiplied, we add them. And like I said, you can get some big numbers here. And then, I don't know what this one is, so I'm going to grab my calculator. Negative 5 times negative 48. 240, and we get positive 240. and then we add. So was that not simpler than the last round? Okay, so once you know where the numbers go, I'm like, whoo, give me this any day. I'd do this over that whole page of long division any second of any day. So not all divisions are hard. Then, is this one, like if they said, what's the remainder, what is it this time?
0.
So the remainder is 0. And the quotient this time, this is my number, this is my x, this is my x squared. So if that helps to do that, go backwards, don't include the remainder though. So we're going to go x squared plus 2x minus 48.
This is fine.
Yep,
You had said earlier that this doesn't work on all of them. How
Right.
are we gonna know when it's not gonna work?
when you have something that is over one thing, like if it had x squared plus 7, can't do it on those. The only ones you can do it on are numbers that look like this. So the divisor can only have x to the first. If it's anything higher, you got to do long division. Okay, so anything that you're dividing by something simple, like x minus 1, x plus 10, you know, anytime you get into like a 2x squared plus 7x minus 3 and you have 3 things, it's a no-go. You can't do it.
So it can only be like x plus something?
Yeah, so basically when you write it down, if you have more than just one number out there, can't do it. And the reason is because we're just focusing on you're multiplying and you're not putting 3 things in there.
Wait, why is there a division there if we're multiplying again? Because that rule says you always multiply?
Yeah, so up here, it said you reverse the sign and that lets you add instead of subtract. So we're adding and multiplying instead of subtracting and dividing.
Okay.
So the long division is dividing and subtracting. Synthetic is adding and multiplying, which makes it so much easier.
So if the sign's already multiplication, does that mean it has to change to division?
No. No, it's just kind of the rule of this one. It changes it so that you don't have to divide to make it easier.
So you can always multiply.
Always multiply. It will never change. Nope. Okay, so do you need to practice another one for that? Are we good with that? Much easier second time around. Everybody okay with that? The only mistake that I usually see is how do you write it when you're done and did you divide by the right number? It's not the process. Everybody generally gets the, oh, I multiply these and I put it here and then I add. Everybody gets that part. It's, did I put the right number on the outside and did I write that correctly? That's the only mistakes that I ever see on these. And that's not a huge deal. It's something that can be easily fixed. So much easier day for you today.